All right, welcome back, and now we're going to talk about analyzing graphs of functions and also piecewise defined functions. So we're going to start with symmetry. So we're going to look at tests for symmetry and the definitions of the different types of symmetries. So this is what we're going to look for when we're talking about testing for symmetry. So what we're going to do is, if we consider an equation in x and y, we look at the graph of the equation, and so this is what we're looking for. If we look at substituting negative x for x, right? So in the equation we take x and we replace it with negative x, and if that, after doing that substitution, it results in an equivalent equation, which means we get the same equation back, that will tell us that the graph of the equation will be symmetric with respect to, that's what this means, with respect to the y-axis. So again, if you replace x with negative x in the equation and then simplify it, and you get the same equation that you started with, you get the original equation back, then that tells you that the graph of the equation is symmetric with respect to the y-axis. Now, the second one says, well, what if I replace y with negative y? Well, if you replace y in the equation with negative y and then you simplify it and it turns out to give you back the original equation, so you get the equivalent equation back, then that tells you that the graph of this equation is symmetric with respect to the x-axis. Okay, so that's what the second bullet point is saying. Okay. The third bullet point says that, hey, what if I replace both x and y in the equation with negative x and negative y, and then simplify it? And what happens if I do that and I get the original equation back? I get an equivalent equation. Then that tells you that the graph of the equation is going to be symmetric with respect to the origin. Okay, so those are your tests for the different types of symmetry. So we have symmetry with respect to the y-axis, we have symmetry with respect to the x-axis, and we have symmetry with respect to the origin. Okay, and so when we talk about the symmetry with respect to the y-axis, that's where if we can fold it across the y-axis, the left half looks like the right half. Okay. If we look at symmetry with respect to the x-axis, then that means that if we fold it up across the x-axis, the top half looks like the bottom half, right? So it will fold up or down on top of each other. And then finally, being symmetric with respect to the origin means that, hey, if I rotate the graph 180 degrees, and about the origin, right? So if I rotate it 180 degrees with respect to the origin and I get the exact same graph back, then we know that that graph is symmetric with respect to the origin. Okay? So for example, if we have, let me see if I have, yeah, so if I have something like this, so that would be symmetric with respect to the y-axis, right? If I have something like this, that is symmetric with respect to the x-axis. And then if I have something like, let's see, if I have something like this, let's assume this is y equals x, right? So if I rotate this 180 degrees, I get the exact same line back. So that is symmetric with respect to the origin. We're going to do more examples and you'll see more of this. Okay, see you then.